Hello everyone, today we are going to talk about problems related to miscible and immiscible liquids. What are miscible liquids? Those liquids which can form homogeneous mixture on mixing are the miscible liquids. Similarly, those which can't form homogeneous mixture are immiscible liquids. So in simple terms, you can say that miscible liquids are the ones which can mix, whereas the immiscible ones are which can't mix. So this is simple definition. Now we'll solve a problem. Two miscible liquids are mixed as shown in figure below. Find out pressure at height h1 by 4 from bottom. So we have to find pressure at height h1 by 4 from bottom in the final container. So we'll write the solution here. So here we are given the dimensions of first and second container, also density of liquid in first and second container, and for third container let's assume the density to be d3, the area is A and height is h1 plus h2. We have to find the pressure at height h1 by 4 from bottom. So this is the point for which we have to find the pressure. This is h1 by 4 height from the bottom. So we'll write that for final mixture or for final solution, the final mass is equal to, let's call it m3. So m3 is equal to m1 plus m2. m3 is the mass of liquid in final solution. Similarly, m1 and m2 are mass of liquid in first and second container. So m3 is equal to, what is m1? It is density times volume. So AH1 is the volume and density is d1. Similarly, for second container, we have AS2 as our volume and d2 as density. So m3 is equal to AH1 d1 plus AS2 d2. Similarly, we'll write the final volume. So final volume, let's call it V3. It will be equal to A times H1 plus S2, right? So A times H1 plus S2. We got the mass, we got the volume. Now we'll write the final density. Final density, let's call it D3, which we assumed earlier. So D3 is equal to, you know the formula for density, it is mass divided by volume. So M3 divided by V3. M3 is A times H1 D1 plus S2 D2, and V3 is A times H1 plus S2, right? So A will get cancelled out in the numerator and denominator. So D3 will be equal to H1 D1 plus S2 D2 divided by H1 plus S2. So we got the value of density. Now we'll focus here. Find out pressure at H1 by 4 from bottom, right? So this is the point for which we have to find the pressure. So here we'll write that height from top will be equal to h1 plus s2, which is complete height, minus h1 by 4, which is height from bottom. So this will be the height for which we have to find the pressure from top. So this height came out to be s2 plus 3h1 by 4. So this is the height for which we have to find the pressure at this height from top. So pressure at h1 by 4 from bottom is equal to pressure at h2 plus 3h1 by 4 from top. So this is the simple equation. So over here we'll write the pressure at height h1 by 4 from bottom is equal to pressure at height, which is that height, h2 plus 3h1 by 4, h2 plus 3h1 by 4 from top. So these heights, the pressure for these two heights should be equal. So pressure will be PATM, atmospheric pressure, plus S3 D3G. What is the value of S3? So it is S2 plus 3H1 by 4. So PATM plus S2 plus 3H1 by 4 multiplied by D3. What is D3? It is H1 D1 plus S2 D2 divided by H1 plus S2, right? Multiplied by acceleration due to gravity, which is g. So this will be our answer. Hope you understand this. And this is h3, right? Simply pressure will be P atm plus H3 D3G. Moving further, we'll solve another problem. Two immiscible liquids are mixed as shown in figure below. Find out pressure at midpoint of denser liquid. So you know what are immiscible liquids which can't mix, right? The liquid with density D1 is the denser liquid here. Also, the pressure at the midpoint of denser liquid will also be equal to pressure at the top surface of denser liquid, right? So we'll write the solution here that pressure will be equal to P atm atmospheric pressure plus H2 D2G, which is this is the denser liquid. H2 D2G is the pressure exerted by liquid which is lighter. So this will be our answer.